Can, sir.
Can you hear me?
Can.
I can't hear the sound. Can you hear me?
Can, sir.
Right? Why no sound here? Can you hear me? Anyone reply? Hello? Can you hear me?
Can.
Oh, okay, thank you. Abhirami, off your mic. Abhirami, off your mic. Okay, I think we can start already, yeah? Okay, before we start the new subtopic, I give you the answers. Okay, I give you the answers for subtopic 1. So subtopic 2 and 3 a bit difficult, so we will go a bit slower. So no need to worry because your exam SPM will be next year. Okay, now I give you the answers. Take note. Okay, answers for the objective questions start from page 3. Objective questions, yeah. Okay, question number 1. Question number 1. Answer is C. 2, D, donkey. 3 is D, donkey. 4, A. 5, D, donkey. Okay, 6 and 7, you skip first for one. 6 and 7, I will discuss when I start subtopic 2. Okay, 6 and 7, leave it first. 8, C. 9, A. 10, okay, 10 answer is A. 11, C. 12, D, donkey. 13, got 2 answers, C and also D. 14, D, donkey. Abhirami off mic, yeah? Okay, 14, D, donkey. 15, B, Bangkok. 16, C. 17, C. 18, D, donkey. 19, B, Bangkok. 20, B, Bangkok. Wait, I check these ones. Okay, wait, I check first. Okay, 21, A. 22, D. 22, D, donkey. 23, C. 24, C. 25. Wait. Okay, 25 answer is B, Bangkok. 26, D, donkey. 27, C. Okay, so that's all for the objective. Okay, now tell me the question that you got problem so that we can discuss later. Okay, tell me the question, sir. Turn on the mic and then tell me. Then we can discuss.
11.
11, okay. Question 11.
22.
22.
23.
23.
25.
25. Turn on the mic and then tell me, yeah? Question number 9.
Sir, can you repeat the answer for number 5?
Number 5. Okay, number 5, answer is D, donkey.
Thank you, sir.
Okay.
Sir, number 12.
Number 12, okay.
4, sir. Number 4.
Okay, question number 4. Next. No more? Okay, if no more, we continue to play. Okay, so now we are going to discuss. So for the discussion, I will present first, then from there we discuss, yeah? Okay, so we can save time, no need to redraw again. Okay, I think you can see. Oh, 16 and 26. I don't have my 16 and 26. Eh? 16 and 26. Okay, then we need to go through a bit detail, eh? So that you can get the main idea of this chapter, and then make sure that you score full mark. Yeah, normally students will lose mark, but if you study detail, no problem. Yeah. Okay, so question number 4. Okay, so question number 4. Okay, all of you have a look on the question 4 in the module. Okay, figure shows the circular coil carrying a current I. X, Y, and Z are plotting compasses. Okay, the needles of the compasses points in the direction shown in. Okay, it's very simple. This one is what? Coil, right? Coil, yeah? Wait, one more. Wait. Wait, I need to message them. Navasri, are you in the group? Navasri, are you in the group? Please reply. Navasri, are you in the group? Hold on, here got problem. Yes. Okay, for the question number 4. Check here. Oh, in the video. Okay, question 4. You see the current here, current flow in which direction? Wait, my pen is not working. Hey. Wait. My pen is not working. Wait. Hold on. No problem with the pen. Sorry, touch. Hold on. I got problem with my. Okay, sorry, just now I got problem. Okay, look at what happened to the participants. I cannot see the participants. Okay, wait, 7%. Okay, at least can help. Okay, look at it. Sorry for late. Okay, question number 4. Okay, they ask you, look at the current over here. Current over here is what? Current over here is upward, right? Okay, it is upward. So if the current over here is upward, on the left hand side is upward, over here is what? Downward, correct? So here upward, over here is what? Downward, inward. So for this one, you look at here. Look at this diagram. Same actually. Current one side is what? Upward, here upward, one more side is what? Downward. So you have to use what? Right hand. You have to use right hand grip rule, so that when on the left hand side, okay, on the left hand side, you can see the current is what? Upward, correct? No? So it will be in the anti-clockwise direction. And then if you come to the right hand side, okay, use your thumb point inward. Your thumb must be point inward, and then curl the fingers. You will get in the clockwise direction. So center will be same direction. Okay, center will be same. So the main answer for the question number 4 is from the diagram number 2. First diagram on page 2. Okay, you can see over there. Okay, so now we go for the, I hope you understand. Okay, use the right hand grip rule. It's a coil, yeah. Okay, then we go for number 9. Okay, question number 9. The magnetic field produced by a current in a long wire, the strength of the magnetic field increases if, okay, I mean, let's say here is we got a very long wire. Okay, a straight wire, the magnetic field surrounding this wire can be increased. Okay, it can increase when magnitude of current increase. Answer yes. If the current increase, what happened? Surrounding it, it will produce what? Stronger magnetic field. So if the current over here, it is increased, the magnetic field produced become what? Stronger. Then you see the B. The distance of the wire increase. Okay, let's see. If you move further away from this wire, move further away, what happened? The magnetic field getting what? Stronger. So magnetic field will become what? Very strong if it is very close. Moving further away, the distance become what? Further. Shows what? Magnetic field getting weaker. Okay, so that means B is not the answer. C, the length of wire increase. So remember, length and resistance. When the length increase, resistance increase, it causes what? Current that flow will decrease. So if current decrease, magnetic field that produced will be what? Weaker. So answer is A. Okay, question number 11. Okay, question number 11. Okay. Okay, for the question 11, you see the current. Okay, the current flow over here is upward. Correct? Upward. 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 Okay. So now, first of all, we identify the poles. Okay, use right hand. Okay, use right hand grip rule. Okay, right hand grip rule. If you use right hand grip rule, your 4 fingers over here must point upward like this. Okay, then what happened? Your thumb will point to the left. That means here will be what? North pole. Here will be south pole. So use the right hand grip rule. So if on the left hand side is north pole and then right hand side is south pole, then you compare with the magnetic field of the permanent magnet. How is it? So here will be what? Away. Here will be towards. Then you see the answer. So at the X, it must be to the left. Okay, on the Y, okay, at the Y, it must be towards. So answer is C. Okay, answer is C. Okay, so now we go for the question number 12. If you're still confused, tell me. Yeah? Okay, question number 12. Okay, what is the polarity of X and Y of the U-shaped electromagnet shown? Okay, I already give you some clues. When you want to come out with a C shape, U shape, or N shape, check first the way they wind the wire. Okay, you see the wire, the way they wind the wire. Okay, here where is it? In front, right? Okay, it is in front. Then come to second also in front, right? So same side. If same side confirm over here, it will be like poles. It will be like poles. So how to produce? I mean, if you want to produce the unlike poles, the wire over here, okay, the wire over here comes to the front, then only goes to the back. Then only over here at the X and Y, it will be unlike poles. Okay, so let's check. Okay, we check the current flow. Where is the current flow? Okay, current flow upward. That means here also upward. Okay, we draw upward. Okay, now use the right hand grip rule. Use the right hand grip rule. What do you get? Okay, at X on the left hand side over here will be north, over here will be south. So over here, how about here? Over here also what? Same. Here north, sorry. Here north, over here south. So they mean at the X and Y, it become like pole, same pole. So please use what? Right hand. Okay, right hand grip rule. Okay, use right hand grip rule. Eh? Okay, I hope you understand. Okay, question number 16. Okay, how can a straight wire produce a magnetic field? Okay, so let's say here we got a wire. We got a wire. How you want to make, okay, surrounding this conductor, it can produce a magnetic field. How to produce magnetic field? So very simple. There must be what? There must be flow of current. If current flow, then only what? It produces a magnetic field surrounding it. If no current, nothing happen. So simple. So if let's say the wire over here, if you bend the wire like this, is it produce magnetic field? No. Okay, or you make the wire, you make the wire in terms of solenoid. Okay, you bend the wire like a solenoid. Is it will produce magnetic field? No. Magnetic field only produced when the current pass through the wire. So answer is what? Answer will be bend the wire, pass through the current in the wire. So answer is C. Number 22. Okay, question number 22. Okay, so this one you have to make sure that you have to make the connections correctly so that the electric bell can ring continuously. Okay. Okay. Diagram shows a simple electric bell with 4 leads Q, R, S, and T, and a battery with 2 leads to give a continuous ringing sound. Which is the correct way to connect up the circuit? Okay, so for that, so first of all, you see over here. Current from the battery must flow to the coil. Okay, must flow to the coil. Then what happened? The soft iron core over here become what? Electromagnet. When it's become electromagnet, it will attract the iron armature. Then current, wait. And then what happened? It will pull the iron armature. And then the current must continue.
Sir, can't hear you, sir.
Now can you hear now? Sorry. Can you hear now?
Can, sir.
Sorry, eh? Is it already discussed these questions now? Can you hear or not just now? No. The electric bell? Hello? Excuse me. Is it just now we already discussed the electric bell? Can you hear just now?
No.
No, sir, no.
No, then I have to move back. Sorry, I don't know why. Okay. Question number 22, 23 also same. 22, okay, ready just now?
Yeah, okay,
It will
okay.
stop at 22.
Oh, 23, yeah? Okay, 23. Wait, I repeat this question. I think hang lah. Okay. So the question is, diagram 23 shows a simple electromagnet. What change should be done to increase the strength of electromagnet? Okay, if you remove the soft iron core, if you remove, what happened? Okay, we got three factors, right? One, increase the current. Number two, increase the number of turns of coil. One was what? We have to use what? Soft iron core. So these are the three factors. So here, if you remove the soft iron, so this is cannot. You cannot produce a strong electromagnet. Okay. Then next, decrease the number of turns of coil. Also cannot decrease it. You have to increase. And then increase the number of batteries. Yes. If increase the number of batteries, what happens? The current increase. If current increase, the strength of electromagnet also increases. So answer is C. But the D, if the diameter of the wire decrease. So let's say if we are using thick wire, okay, thick wire, resistance what? Low. If you are using thin wire, resistance will be what? Okay, resistance will be high. If resistance high, current flow become what? Low. So if you decrease the wire, resistance high, current flow become low. So they mean answer is C. Yeah. Okay, then we go for the question number 24. Right, 24 now.
Sir, you didn't finish explaining the question number 22.
Right? No. Oh,
Yeah.
just now you cannot hear.
Yes, yes.
The next time, if again, I don't type in the chat box. I won't see the chat box here. Okay, if you type in the Telegram, then maybe it can blink over here, then I can see. Yeah. Okay, we can't hear. Right? Coagulant. Wait. Let's see. Okay. So question number 22. So you want the bell to ring continuously. Okay. So what you need to do, you have to connect the bell terminals correctly. Okay. So have a look over here. If let's say I connect, okay, over here, what happened? Current flow. Yes, current flow. Current flow in the coil in the electromagnet. Okay, this is the part where the current flow. They come to T. See, lost contact. So what you need to do? What? Wait, Coagulant. The others can hear, but okay. So when come to R, it stop. But then you have got one more terminals, right? So what do you need to do? You have to connect the battery to here, and then you have to use one more extra wire so that current flow can continue. Okay, R2. Oh, sorry, not here, not here. Not here. Okay. So you have to use extra wire to connect the point R and S. Then only current can flow to the screw contact, then to the battery again. So that means in this case, what we need to do? We need to connect the terminals of the battery. Okay, terminals of the battery between the Q and T, and then you have to use extra wire to connect the point R and S. Wait, Next time join with audio, audio. Okay. Then we go for the next question number 23. Finish. 25. Okay, 25. Just now we missed this. Diagram shows a setup of the apparatus to study the pattern of the magnetic field produced by the current in a straight wire. Which diagram shows the correct pattern and the direction of the magnetic field will be seen by the observer. Okay, this one actually is very simple. Okay, you see the current flow. Where is the current flow? Current flowing upward. So if the current is flowing upward, okay, so upward, so we have to use what? We have to use the right hand grip rule, curl the fingers, look at what? Direction of the current, and then your thumb. Okay, your thumb must point what? Okay, must points to the, okay, sorry, I'm not good in drawing. So here is your thumb, points upward. So curl the fingers, you will get in anti-clockwise direction. Okay, anti-clockwise direction. So you check the answer over here. Anti-clockwise. Is it anti-clockwise? No. Okay, how about this? Is it anti-clockwise? No. How about B and D? Yes, B and D, it is in the anti-clockwise direction. Okay, it is in the anti-clockwise. But anyhow, if you look at the conductor here, you place it here. This is a current flowing upward. Is dot. So we draw close to the conductor. It must be closer. When we move further, it must be what? The lines, so what? Getting further. Why? Because further away from the conductor, the magnetic field getting weaker. Okay? So when we move further away, you see the distance. You see the distance over here. Further right. Why? Because when you move further away from the conductor, at the middle, the magnetic field getting weaker. Simple. Okay? So now we continue with the question number 26. Okay, 26. Which of the following electromagnet has the weakest magnetic field? So keyword is what? Weakest. So remember the three factors: number of turns of coil, current, and then the use of soft iron core. So here you can see in the C and D, no soft iron core. So sorry, it cannot produce a strong electromagnet. So answer is what? A or B. Because why? Because here they are using soft iron core. And one more, you see number of turns of coil. And also you see the battery. Number of turns of coil is more, battery also more, so current flow is higher. So it will produce a strong electromagnet. I mean, they try to test over here the factors that affect the strength of an electromagnet. So answer is A. Okay.
So they are weakest magnet. Magnetic.
Weakest. That means just now I give you the strongest, right? Strongest. So that means that means this one strong. This one is so strong, but compared to this one strongest, right? Strongest, yeah. And then the B is what? Stronger. And then C and D, yeah? C and D. So you see a C, battery more, number of turns of coil is more. But then D, battery is less, number of turns of coil is less. So the weakest is what? D. The weakest is D. Because no soft iron core, number of turns of coil is less, and then battery is what? Less. Current flow is what? Less. Okay, so finish the objective questions. Okay, now we go for the structured question. Okay, structured question. So we have to go a bit fast. Okay, question number 1. Figure 10.1 and 10.2 shows two identical electromagnets, X and Y. The current in X is 2.0 ampere and the current in Y is 3 ampere. You can ask like this in the exam. Very easy to score. Don't lose single marks. Okay. So normally they will give the diagram for the emitter. So you check the reading of the emitter correctly and then only you compare. Okay. So what is meant by electromagnet? So answer simple. You just write these two words. Temporary electromagnet is now. Temporary electromagnet. Okay. Temporary electromagnet. Okay. For the 2, finish it. Using figure 10.1 and 10.2. Compare the amount of iron flings attracted and okay, so the amount of iron flings attracted, underline number 1, And then the magnetic field strength of the electromagnet, number 2. Okay, relating the current in the amount of ion flings attracted, number 3. And deduce the relevant physics concept, number 4. So they mean here lack of 1 point, yes. So it's already happened like this in SPM. So if lack of 1 point, you try to write, and whatever you want, you write. But normally nowadays they will give the points in the question straightforward. Okay, so now I give you the answers. Please take note. So first one, please write in a sentence here. Point form, okay, like this. Okay, write first. Amount of ion fillings, okay, attracted in diagram 10.4 is more, is less, yeah, less than 10.5. Use the symbol. It's less than 10.4. Hey, 10.5. Okay, 10.5. Okay, this one, correct, yeah? Okay, so use the symbols of this. But before that, you tell first what you are comparing. Okay, please tell. Oh, sorry. Okay. You have to tell these points. Write this first. Okay, write this, then only followed by the symbol. Easy. Okay. Then next one is magnetic field strength of the 2 electromagnets. Okay, you write magnetic field strength of electromagnet in diagram 10.2. Wait, why 10. Hey, something is wrong here. 10.4, 10.5. 10.4, 10.5. Okay. I got it. So that means this one you have to remove. Because when they convert, there's a one diagram hidden down there. So we have to cancel this. So then the answer also must change a bit. So not 10.4, sorry. Not 10.4. So the answer will be 10.1 less than 10.2. There's one more diagram is hidden down there. So it's wrong. Okay, so next one is magnetic field strength of the electron, 2 electromagnets in diagram 10.2 is 10.2. We write 10.1 first. Okay, 10.1 is less than 10.2. Actually, you can write magnetic field strength in diagram 10.2 is stronger. Magnetic field strength in diagram 10.2 is stronger. Okay, then the third one is current and the amount of ion fillings attracted. So please write, when current increase, amount of ion fillings attracted also increase. When current increase, amount of ion fillings attracted also increase. When current increase, amount of ion fillings attracted also increase. Okay, when current increase, amount of ion fillings attracted also increase. Okay, then the last one is the relevant physics concept. What physics concept is it? About the strength of electromagnet. So here, when the current increase, what happened? You can see more ion fillings attracted. So the more the ion fillings attracted, it shows what? Strength of the electromagnet. So here we can write, when current increase, strength of electromagnet also increase. When current increase, strength of electromagnet also increase. Wait, when current increase, strength of electromagnet also increase. Yes?
Can I write current is directly proportional to the magnetic field strength? The last point one.
Okay, can, not to say cannot, but dangerous. Not cannot, not say cannot, can. But here, because of we are not using any graph, right? So better write some sort of writing hypothesis for safety purpose. Because some school teachers, they don't want to give. Wait, what happened? Wait. Wait. Can see now? Okay. So just now your question. Oh, wait. Just now your question is, can you that directly proportional? So try to what? Because here we are not using graph. So if you're not using graph, better write some sort of writing hypothesis. Easy. Yeah? Can I?
Yes, sir. Thank you.
Or you also can write greater the current, greater the strength of electromagnet. Okay, the next one is name a device which uses electromagnet. We can write electric bell, circuit breaker, telephone earpiece, lifting electromagnet also can. Yeah. Okay. Now we go for the question number 3. Diagram figure 10.3 shows a large electric current passing through a vertical wire. Copy the figure 10.3, then sketch on the card the pattern of the magnetic field produced by the current. Indicate with the arrow the direction of the magnetic field at any point. Okay. And then how will you check this direction experimentally? How you're going to check the direction experimentally? How? Okay, never mind. We draw over here. How about direction? It is in the clockwise or anti-clockwise. Current is in what? So it will be in clockwise direction. Correct? Okay, we draw. Okay, so they will give you 2 marks. One for the pattern, the circles, direction, and one more is how you're going to check the direction experimentally. Answer. How you're going to check the direction experimentally? Anyone?
Using compass.
Use compass. Yes. Don't say use right hand grip rule. Sorry, it's not accepted. We have to use right hand grip rule. Hey, use compass. Sorry. Use compass. Okay. Finish. Okay. So we go for the next one. Is question C. Okay. Question C is 2 identical solenoids. Okay, 2 identical solenoids. Shows the insulated copper wires. Sorry, maybe number 2. Identical solenoids. One with a metal core X, and the other one as the metal core Y. Each solenoid is connected to same power supply. Okay, what they said over here? Same power supply. Same. That means what? Current same. Yeah. For each apparatus, the switch is put on, and the core is dip briefly into the iron fillings. That means you bring it and then touch the iron fillings. The amount of iron fillings attracted by the rods are shown in the figure 10.4 and 10.5. So here, okay, here you can see the iron fillings, in both diagrams. Okay, for the 10.4, 10.5, it's what same. Okay, the current in each circuit is then switched off. The amount of iron fillings attracted by the rods are shown in the figure 10.6 and 10.7. So they didn't ask question like this in the exam. Yeah? So this one, when the switch is on, here is on off. So after you off, what happened? After you off, what happened? So you compare 10.4, 10.6, 10.5, 10.7. So using the results of the experiment, distinguish between the magnetic property of Y. Magnetic property. Okay. What material is the metal X? So the metal X is what? You see the amount of iron fillings attracted. What happened? More, and then after switch off, most of the iron fillings drop. That means it is a good electromagnet. That means it is soft iron core. Okay, so you write over here, soft iron core. Soft iron core. And what material is metal core Y? Metal core Y, you see over here? Iron fillings attracted, still what? Still remain there. So it is steel. Steel core or steel. Then which material is suitable to make the core of electromagnet? So you want to make an electromagnet, good electromagnet. So we have to use what? Soft iron. So we can write soft iron or X also can. X or soft iron. Okay, X or soft iron. And then which material is suitable to make a bar magnet? Bar magnet means a permanent magnet. So permanent magnet, we can choose because it not lost its magnetism after the current was switched off. So answer is what? Metal core Y, or you can write steel. Yeah, metal core Y or steel. Okay, then we go for question number 2. Another question that normally they will ask in question number 10, comparison. Yeah, okay. Diagram 10.1 and 10.2 shows the insulated copper wires are wrapped around the rods to form solenoids. The solenoids are connected to emitter, rheostat, switches, and risers. When the switch is on, the paper clips attracted to the solenoids. Okay, what's the difference? What's the difference? So the difference is, okay, the difference is you see the number of turns of coil, then you see the battery. So must observe the diagram carefully. Don't lose any marks. Okay, so answer over here. What is meant by electromagnet? Okay, just now we discussed it's a temporary magnet. Okay, we go for the B straightforward. Using diagram 10.1 and 10.2, compare the number of turns in the solenoid. Okay, so what you are going to compare? Compare the number of turns. Number 1, magnitude of the current flowing. Number 2, and the number of paper clips attracted. Number 3. So write in point form, I tell you. So you write in point form and then followed by the symbol greater, lesser, or equal. Okay, so answer for the first one is number of turns in solenoid in diagram 10.1 greater than 10.2. Right like this. But before that, you tell first what you're comparing. Okay. So the next. Finish. Okay. Next one is the magnetic current flow. Okay. Current flow in diagram. Current flow in diagram 10.1 greater than 10.2. Current flow in diagram 10.1 greater than 10.2. Current flow in diagram 10.1 greater than 10.2. Okay. Then the last one, number of paper clips attracted to a solenoid. Okay, repeat the statement. Number of paper clips attracted to a solenoid in diagram 10.1 greater than 10.2. Number of paper clips attracted in diagram 10.1 greater than 10.2. Number of paper clips attracted in diagram 10.1 greater than 10.2. Okay. And then next is the relationship. State the relationship in strength of magnetic field and the magnitude of the current. Strength of magnetic field and the magnitude of current. So answer, when magnitude of current increase, strength of magnetic field also increase. When magnitude of current increase, strength of magnetic field also increase. Or you can write greater the magnitude of current, greater the strength of magnetic field, also accepted. Okay, so the next one is the number of turns in solenoid and the strength of magnetic field. So answer, when number of turns in solenoid increase, when number of turns in solenoid increase, the strength of magnetic field also increase. Okay, next one. Question number, oh, the next one, there's no question number, yeah? This one, question number 2. Actually, this one must be, oh, same question. Same question. Okay, so now let's check. Diagram 10.3 shows a simple electromagnet consists of a solenoid with a soft iron core inside. The two magnet bars are hung freely at both sides of the solenoid. Explain what happened to magnet P and Q. Actually, this question is very simple. But if let's say we didn't discuss, then yes, you're confused. You don't know what to write. So answer it. Okay. So when the switch is on, what happened? Okay, so here you can see there's the two magnets. Yeah, two magnets. Okay, magnet P, magnet Q. Okay, magnet P and also magnet Q. So here when the switch is on, what happened? Current flow. When current flow, so you can see over here current flowing. When current flow, what happened? One of the end become what? North pole. One more end become south pole. So which end become north pole? So use the right hand grip rule. Right hand grip rule. So here will be north. Over here will be what? South. So curl the fingers upward. For the 4 fingers must be what? Upward. Then your thumb will point to the left hand side, north. So now you see on the left hand side. Okay, on the left hand side over here is a like pole side. Right hand side is what? Unlike poles. So the question is explain what happened to magnet P and Q. So answer magnet P repel. Okay, right? Magnet P repel. Magnet P repel. Okay, magnet P repel because Na, E and D, Na become north pole. Because Na become north pole. Because Na become north pole. Okay, then we go for the right hand side. Magnet Q attracted. Magnet Q attracted or attract because magnet Q attracted because NB become south pole. NB become south pole. Because NB become south pole. Okay, finish. Okay, then the next question is a D. Diagram 10.4 shows the electric bell connected to dry cells. Explain how the electric bell functions. 4 marks. So for this one, you can copy from what I gave you last week. Okay, when the switch is closed, current flow in the circuit. Soft iron core become electromagnet. It attract the soft iron armature. Okay, soft iron armature attracted. Hammer strike the gong. Contact open. Okay, spring pull back the armature to its original position. Current flow again. Process repeated. Can you hear? Can you get the answer or not?
Can, sir.
Can, sorry, wait, got noise at the back. Wait. Okay. Today a bit noisy because of my neighbor. They are renovating their house. Okay. So question number 3, I think I won't discuss the question number 3A and also B. Now you want to discuss can, but before that, I have to discuss this question here. Question number 3. E, you have to wait. Okay, E. Question 3, you skip first. Question number 4, yeah. Once I back to the tuition center, you show me this experiment, I will check. Yeah. Okay. So now I want to stop presenting.
Sir,
Yeah.
modification one,
Which one?
the bell question.
Oh. Explain the modification that needs to be done to the electric bell to enable it to rings louder. Okay. So they give you 6 marks, right? Okay. They give 6 marks. We will discuss the points when come to the passage question. Okay, no? You will get the points over there. I will repeat. So what we can do is what? Wait, I just tell you, don't need to copy anything. We can use what? Okay, here they already give one, stop and go. Okay. We can increase the number of turns of coil. We can increase the current. Okay. We can use what? One more is what? Larger gong. Because larger the gong, louder sound produced. Why? Because inside got more air. So it vibrate, more air vibrate, louder sound produced. Okay. So all these points we'll discuss again when come to the passage question. Okay or not? So I want to skip first. Because a long way to go. This chapter, especially subtopic 2 and 3, take time. Okay. So 3, I'm going to discuss now. But before 3, wait, stop the presentation. All of you have a look on the whiteboard. Okay. Before we continue the subtopic 2, force acting on a current carrying conductor in a magnetic field. Kavin Prasad, off your mic. Okay, let's say here got a 2 wooden plank, and then we place 2 thin metal strips. Okay, we place 2 thin metal strips over here, or copper wire also can. Okay, 2 thin copper wire. 2 thin copper strips of copper wire. And then what we are going to do is, at this point, let's say here here Q, R, okay, P, Q, R, S. Okay, so I want to connect these 2 points with the terminals of battery. Okay, battery. Current flowing, right? And then current flow. But this is the wooden plug. This is a thin copper wire or copper plate. And then Q2R over here, I place another wire. You can zoom in the diagram because later I'm going to draw one more diagram on the right hand side. You need to differentiate so that you can answer the object question number 5 and 6 if not mistaken. Yeah. Okay. So here current flowing. Current flowing. So when the current is flowing, as you already learned in the subtopic 1, when current is flowing in a straight wire, what happens? Surrounding it, it produces what? Magnetic field, right?
Can't see you, sir.
Can't see. Right? Can you see or not?
Can see, sir.
Can.
So are you presenting?
I'm not presenting now. புரியுதானே?
Yes, sir.
The others can see. I think your side no problem. Out. Okay, log out and then join again.
Okay, sir.
Okay. Okay. So when a straight wire is conducting current, what happens is surrounding it produces a magnetic field. Okay, surrounding it produces magnetic field. So if surrounding it produces a magnetic field. No, only one by one joining. Can you hear me?
Yeah, can, sir.
Can,
Okay.
sir.
It's noisy. Yeah. Okay. Now, so when a straight wire is conducting current, what happens? What surrounding it produces a magnetic field. Okay, it produces magnetic field. So here there's a two wires there, PQ, okay, PQ, and then also RS. It is conducting current. So when these two wires conducting current, what happens is these two wires maybe it will bend outward, or maybe it will bend inward. So in which direction these wires will bend? Why it bend? Because of the magnetic field that produced surrounding this conductor and also the magnetic field surrounding this conductor. That's why it will bend. So in which direction it is going to bend? Okay, let's check. Okay, so let's assume that you're observing this diagram from the top. Okay, you're observing from the top. You're looking into this diagram from the top. Okay, so if you're observing from the top, okay, left hand side. Okay, first step is what? Current flowing. Current flowing from where? Current flowing from P to Q. Okay, from P to Q. And then over here is what? Inward. Correct? It is inward. Current flowing like this. Okay, current flowing. So if you're observing from the top over here, what do you see? Current is out. So on the left hand side, current is flowing upward from the top. Remember this? Upward. What you will see? You will see the dot. Correct? On the left hand side is a dot. So on the left hand side over here, we draw a dot. Current is out of the surface, and then current is out of the surface, and then we draw the magnetic field. Clockwise, anti-clockwise. Current is out. Your thumb must be points upward. Curl the fingers. It will be in the anti-clockwise direction. Okay, it will be in the anti-clockwise direction. Okay, so this one for the conductor on the left hand side. Now come to the right hand side. So if you look at the right hand side, what happened? Over here, current is in, correct? So on the right hand side is current is in. If in, so you take the arrow. If the arrow is what? Pointed downward, what you see? You will see the tail, right? The tail from the top. You will see the tail. So on the right hand side, I put cross because of current is into the surface. Cross into the surface, and then we draw the magnetic field. It is clockwise or anti-clockwise direction? current is in, curl the fingers, you will get in clockwise direction. Okay, you will get in clockwise direction. So what happened at the center? So at the center, you can see the magnetic field is the same direction. That means in this diagram, the answer is what? Same as the magnetic field due to current in a coil. Current in a coil. Hold on, yeah. Close the door. Close. Okay. So here, center magnetic field is what? In the same direction. So you look at the page 2 in the module. Page 2 in the module. The first diagram, the current in a coil. Okay, magnetic field due to current in a coil. So you will see what? Center is what? Same direction, right? Same. Same direction. So it's the same actually. Same. But situation is already new over here. Okay, the situation is already new. Okay. So, but in the exam, if you draw this, they won't give you full mark. Okay, they can give you 2 marks maximum. But it can goes up to 4 marks. Okay, let's check. So the resultant magnetic field. How about the resultant magnetic field? So the resultant magnetic field will become like this. So center is what? Same, right? Same direction. So the resultant magnetic field. Next one, I can draw it smaller. On the left hand side, it is dot. Over here, it is cross. So center is straight, upward. Center is upward. 1. Okay. So center, it is same direction. Okay. So if you draw like this, they can give you 3 marks. Must know how to draw. Draw. Must know. So this one important. Okay. Okay. So extra one, extra one. So if you look at these 2 conductors, when this conducting current as shown, one is upward, one more is downward. Okay, one is upward and one more is downward. So what happens is surrounding produce magnetic field. Well, here's what magnetic field. When the magnetic field combines the back, so at the center, here, you see, same direction, right? So at the center, so same direction. So when it's same direction, all the magnetic field pass by. So let's say 2 of you standing, 2 of you, very close, with a small gap. If let's say your friend wants to pass by, if all of your friends pass by in between, what happens? All your friends pass by in between, sure they will push you upward, right? They will push you upward. Okay, they will push you upward. So what happened? Here, this copper wire, it is being held by the wooden rod or wooden plank. So if nothing is holding over here and here, what happens? It will move away. But because of it is being held on top and at the bottom, so center it got more magnetic field. So what happens? It push the conductor where the conductor will bend outwards. Okay, because of magnetic field, what? Center. So if you need to draw the arrow like this and write F, it can goes up to 4 marks for this. It can give you 4 marks. Okay, 4 marks for this diagram. I mean, answer for the question number. See the module, eh? See the module. Page 8, question number 3. Eh? Question number 3, D. Question number 3D. Diagram 10.3 shows the thin copper strips PQ and RS connected to the circuit. Explain what happened to the PQ and RS when the switch is on. So answer is this answer. You can draw and explain. So just draw and label this. They can give you 4 marks. Or if it's, let's say some students they draw over here. Or this wire bend upward. Okay, it is bending outward. And then you will label with the F over here. Also marks even, but not full mark. Full mark for this diagram. Okay, full mark is for this diagram. Okay, so this one, current that flow in a two conductor which is placed very close to each other and current flowing in the opposite direction. One is upward, one more is what? Downward. Okay, one is upward, one more is downward. Okay, so now I'm going to redraw again this diagram, but with a small difference. With a small difference. So let's see what is the difference. It must be thin copper strip here, cannot be thick. Must be thin. Okay, got two thin copper strips over here. Okay, same like this now, but what I'm going to do is I connect a wire over here and one more over here. Then these two thin copper strips conducting current, and let's say if you are observing this diagram from the top. Okay, I label with the same letters P, Q, R, S. Okay. First step is we need to identify current flow in which direction. Okay, in which direction the current is flowing. Okay, first step, you see the terminals of the battery. Positive, negative, positive, negative. So current flow from Q to P. This is the direction of the current flow. And then, how about the right hand side? On the right hand side, current flow from R to S. It is also what? Downward. Current is what? Downward. So on the left hand side, this diagram, current one upward, one is downward. Here, Both is what? Downward. I'm confident they won't teach this in school. But this one of the concept that you need to know. Yeah? So make sure you understand. Yeah? So here in these two diagrams, both conductors conducting current downward. So how about the magnetic field that form over here looks like? How it will looks like? Okay. So if you observe it from the top, over here current is what? Current over here is in. Over here is what? In. So left hand side, current is in. I put dot. Sorry, it is a cross. It is cross. Okay, magnetic field. Will be clockwise or anti-clockwise? It will be in the clockwise, anti-clockwise. Current is in. Curl the fingers.
Clockwise.
Yes, it will be in the clockwise direction. So this one for the conductor PQ, PQ. Okay, conductor on the left hand side. Okay, now we go to the right hand side. Right hand side, RS. RS also what? Current is inward. So for the inward, I use different color. Yeah, I use a red color. Also, it is in. So I use cross in. And then the magnetic field. Clockwise and anti-clockwise on the right hand side. So on the right hand side, current is in, some points inward. Curl the fingers. You will get still in the same direction. It is in the clockwise direction. Okay, it is in the clockwise direction. Okay, finish. Now, okay, you see over here. You see over here the two colors, red and the black, when passed through over here center, because of same direction, all combined same direction, right? But here is different. Okay, for this one, okay, you see over here, black color, red color, black color, when pass come to here, when meet with the red line, what happen? It will force this magnetic field to go up. I repeat, when this, or let's see, when this red line magnetic field comes over here, when meet with the black magnetic field, what happens? This one will be forced to go down. If you push this to go down, and what happens? Output. So that means the number of magnetic field lines at the center become less. So outside will be more. Because the magnetic field that one goes in, okay, the magnetic field that one goes in, it will be forced to go out. So the number of magnetic lines at the middle become lesser. So the resultant magnetic field, okay, the resultant magnetic field will be like this. On the left hand side, it is cross. Right hand side also cross. Both sides cross. We draw a circle. 1, 2. So the magnetic field that want to goes in over here, it will be forced to goes out. Okay. So the magnetic field that want to goes in, it will be forced to goes out. So it will form the magnetic field patterns. Okay, magnetic field patterns like this. And then here will be what? Downward. So when one to goes in, it will be forced to goes out. And then here upward. So what happened? The number of magnetic lines in the middle become what? Lesser. When less, over here is what? More. See, 1, 2, 3. 1, 2, 3. So 3, 3, 6, right? Total 6. But in the middle, only 2. Sample, yeah, sample. So what happens is the number of magnetic lines in the middle become lesser, and then outside become what? More. So it will cause what? Force acting. So we can draw the arrow like this and label with the F. Label with F. So the force over here acting towards, which makes these two wires to be pushed to move towards each other. So that means it will bend. Okay, it will bend inward. Okay, it will bend inward. And then don't forget to draw arrow inward and write F. Must know how to draw, yeah? Especially this one. This one just want to get the idea so that you can get the final answer. How it looks like. Okay? Okay, I think you can continue. Okay? Okay, so this extra thing that I teach you, which related to subtopic 1 and also 2, but 2 is involved magnetic field. But here, magnetic field due to current in a conductor. But over there, next subtopic, we are going to go see the combination with the magnetic field of the permanent magnet. But here, no permanent magnet. It's a bit difficult, yeah? This one considered difficult for the students. Okay, so next one, subtopic 2, 3.2, force acting on a current carrying conductor in a magnetic field. Okay? Force acting on current carrying conductor in magnetic field. Force acting on a current carrying conductor in magnetic field. Before I continue one more, for next week onward, your class Friday is same, but only a Saturday class, I'll make the changes. Time will be Saturday 9 a.m. to 11 a.m. Yeah. Now I start 10 to 12, but next week onward 9 to 11. Yeah. Okay. So force acting on a current carrying conductor in magnetic field. Okay. Let's say if you're given two magnets. Okay, here's the C-shaped or U-shaped iron core. Okay, iron core. And then I attach with two magnets. Attach with two magnets. Okay, two magnets, and let's say one is the north pole, one more is south pole. Okay, so here let's say it is a north, over here is south. And these two magnets are facing each other, and then in between got what? Magnetic field. So what does it mean by magnetic field? Meaning of magnetic field is region where magnetic force active. You can take note. What does it mean by magnetic field? Take note, please. Definition for magnetic field: region where magnetic force acting. Region where magnetic force acting. Okay, so here in between got magnetic field, but we can't see the magnetic field. And then one more is, let's say if I place a conductor. Okay, now I want to remove this line. Look at this. I want to remove this line. No disturbing here. Okay, I remove. I hope you understand. So in between over here, I'm going to place a conductor. Let's say it is a copper wire. Okay, it is a copper wire. If the current is flowing in this copper wire, current flow. So for this, what I'm going to do is, I want to connect it to a battery. So one of the terminal is a positive, one more is a negative. So now current is flowing. Okay, current is flowing. So if current is flowing, what happens? Surrounding this conductor produce magnetic field. Like this. This conductor, conducting current. Okay, current, where is it flowing? Okay, current is flowing inward. Okay, this is a direction of the current. Yeah, direction of the current. So when the current flowing in a straight wire, what happens? Surrounding it produce what? Magnetic field. Right? Produce magnetic field. And somehow over here got magnet. North over here is south. What happened? Now here got magnetic field of the permanent magnet. So what happened? These two magnetic fields will combine to produce a resultant magnetic field. When these two magnetic fields combine, there's a resultant magnetic field, and there will be a force acting on that conductor. Force acting. Okay. So we are not going to draw this. We are going to draw another diagram. So I repeat. So here positive terminal, over here negative terminal. So here current, this is the direction where the current is flowing. Current flow where? It is flowing into the surface. So let's say if you are observing from here. Okay, if you are observing from here. Oh, current where? Current is flowing in. If current is flowing in, we have to put dot or cross. We have to put current in. Let's say this is an arrow, right? Arrow, eh? You directly in, you are looking at the back. So it's a cross. If current in, you have to put cross. So here we put cross. Current into the surface, magnetic field clockwise or anti-clockwise. Magnetic field clockwise, anti-clockwise. Use the right angle rule. Current is in. Current is in.
Clockwise.
Yes, it is clockwise direction. Okay, it will be in the clockwise direction. I mean this one, the conductor, the conducting current surrounding it produces a magnetic field like this. And some more here is a magnet, permanent magnet. So here, let's say we got a permanent magnet. North over here is South Pole. Okay, but you try to draw it separately. Yeah? Okay, so there will be magnetic fields. This is a flat magnet, so the magnetic field looks like almost uniform, but actually it's not uniform. Okay, but we need to come out with another shape of magnet. Also can be the question exam. Okay, so the magnetic field at the center is what almost uniform. Okay, almost uniform, but actually it's not uniform. And then here it will what? Curve outward. So it is not uniform. So this is a magnetic field from the permanent magnet. So I draw separately here. One for the conductor, the conducting current surrounding it produce a magnetic field like this. Number two, when you place a two magnets, it will produce a magnetic field like this. But if you move the magnets further away, what happens? The magnetic fields can become weaker. So you need to place very close and then let a conductor the conducting current. So when both magnetic fields combine, it will produce a resultant magnetic field. So how about the resultant magnetic field looks like? Before we go to that, okay, let's say we combine these two. I mean this conductor, the conducting current, this one, conducting current. All of you listen, yeah? The conductor, the conducting current. Okay, what happened is inside. So then surrounding it produce magnetic field. If you bring this and then put it inside, because the combination, you bring this and then put it inside. So these two magnetic fields will combine to produce a resultant magnetic field. So how about the resultant magnetic field looks like? But before that, have a look on this. Okay, this is a magnetic field due to the conductor that conducting current. And then over here will be magnet. Okay, on the left hand side, it is a north pole. Right hand side is south pole. There will be magnetic fields like this. Now you can see it is going to combine the magnetic field from the permanent magnet, black color, and then the magnetic field from the conductor, the conducting current, the blue color. Both combine to produce resultant magnetic field, which will produce force. Okay, so later I teach you how to identify the force, but before that you must know how to draw. So in the exam, maybe they can ask you to draw this and also this. But when you combine together, it won't become like this. That's one more answer that you have to draw. So after this, I'm going to show you that. Okay, how about the resultant magnetic field? Okay, please practice. Aisha, are you in the group? Join ready? Okay. Finish? Okay, so now you're going to go through the resultant magnetic field. Next will be more difficult. And I will send you one more diagram you have to print out on your own. Okay, so the resultant magnetic field will be like this. Most important is this. North. Over here is south. Okay, and then the center is current is in. Okay. Okay, so all of you will look on these two colors here. One is the black color, one more is what? Blue color. So magnetic field from the permanent magnet, and then magnetic field due to the conductor, the conducting current. So it both combined. See, we see over here. This magnetic field, the blue color magnetic field, when move come until here, what happens? It will meet with the black color. What happens? When it's moving the curve part, means over here what happens? It will be forced to go up. I repeat, the blue color magnetic field, when it comes over here, sorry, is in the curve part. So when meet with the black color magnetic field, what happens? It will push to go up. I mean, the magnetic field below will be reduced because it will be forced to go upward. Okay, the magnetic field over here will be forced to go up. Then will downward. Okay, so when the magnetic fields forced to go up, must learn how to draw. Because when you draw, sure, many of you will draw in the wrong way. Later I'll tell you how the students will draw. Okay. It will be like this. Okay, it will be like this. Where most of the magnetic field lines will be, most of the magnetic field lines goes upward. But some students, they will draw like this. Some students, they will draw north, south, current is in, they will draw. Okay. It's wrong. Do what? We practice. So here you see the magnetic field that want to goes down. If it force goes up, then go downward. Then how about the direction? The direction don't miss. Also they give you mark. Direction of the magnetic field. So the magnetic field will be force goes up, which cause what? The magnetic field lines above the conductor become more. So more magnetic fields above. So let's say when you are standing alone over here, many of your friends pass by at this side. What happened? They will push you to move to the right, right? Because many of you over here. So when the magnetic field line is more above, it will produce a force from this conductor, which will be pushed downward. Okay, which will be pushed downward. Okay. Okay. So next one. Okay, actually we can use a rule to identify the direction of the force acting. Okay, we can use the rules. But anyway, in the exam, what they will do is what they will ask the students to draw the magnetic field, then followed by the direction of the force. Then they will ask the rules. Okay, actually, you can use a rule. We call it as a Fleming's left rule. So we say this as a Fleming's left hand rule. Okay, for the Fleming's left hand rule, your left hand, please. Your left hand, please. Okay, first, 5 fingers. The 3 fingers you close, and then point like a gun, fire. Okay, fire. Aisha, any problem with you, Aisha? Okay, point like gun. First, your left hand here, point like gun. It must be 90 degree here. It must be 90 degree. And then we move to the third finger, the middle finger, right? The middle finger, third finger over here. You make it downward, show downward. And also you can see it is what? Perpendicular. 90 degree. Okay, first you see over here, 90 degree, your thumb and the pointer is what? 90 degree. And then the middle finger and the pointer is what? Also 90 degree. I mean these 3 fingers, the left and right, left hand, each must be 90 degree. I know some of you got problem. Your place are these right. Yes. Off your mic. Okay. So each fingers over here must be perpendicular to each other. But some students will place like this. They cannot bend. So if you are having problem, we got another roots. We say right hand slack rule. Right hand slack rule. Never mind, I don't want to teach that right now. Can replace. Okay, wait. So Fleming's left hand rule. Each fingers must be what? 90. And then if I give you thumb tag, I ask you to press on the board. Which finger you use? Okay, can go around 1 o'clock. Off your mic, please. Who is that? Okay. Now, so you will use your thumb. Use the thumb. So thumb will exert a larger force. So you write F. You write now on your thumb. Write F. Write F. Okay. And then the 2 more fingers over here. Okay, you see these 2 fingers. Which one is longer? The middle finger, right? Longer. So current symbol is what? I, right? I, current. So this one we write I. We write what? I. Okay. And then for the magnetic field of the permanent magnet, we will write over here with the letter F. With the letter B. If you go for further study, you will see this. Magnetic field will be represented by letter B. So you can see what letter is this? You see over here? FBI. You know FBI? Federal Bureau of Investigation, FBI. In US, right? FBI. Remember the flow, FBI. FBI. But anyhow, these 3 fingers must be perpendicular to each other. It must be perpendicular. So, this finger, the third finger here, the middle finger is what? Current. Okay, let's have a look here. In this diagram, where is the current flow? Current flow in. Okay, this finger, right? The third finger over here. Okay, direct, follow the current. Current back. In. Okay, current in. Okay, I place this in. Okay, current. Third finger. Current is in. Okay. And then the pointer, the second finger, must follow the magnetic field. You see the magnetic field. Not follow the arrow. Arrow to the south. So always here, the second finger over here, you direct to the south. Turn. Direct to the south. Where your thumb points. Your thumb points is a force. I mean, force acting on this conductor. Where is it? It will be downward. So the force acting downward. Okay? So force acting downward. Actually, we are moving towards a motor. Yeah? How a motor can be turned. How we can rotate. Okay? So force acting downward. Okay, let's check over here. Is it correct or not? They ask you to draw this. If drawing this, they can give you 1, 2, 3, 4 marks. Yeah? They can give you 4 marks just for drawing this diagram. Okay, let's check using Fleming's lateral rule. Okay, Fleming's lateral rule. Your third finger over here is what? Current. Current where? Current is in. So if current in, you point the third finger in. In, yeah? In. And then magnetic field, north to south. North to south. I repeat. The third finger is what? Current. Current is in, north to south. Turn your hand. North to south. And then where your thumb? Your thumb points downward. So the force acting downward. So what rule you are using? You are using Fleming's lateral rule. Okay, you are using Fleming's lateral rule. Okay. So now I want you to draw always the second finger towards south, fire towards south. The third finger current in or out. And then your thumb will indicate the direction. So to draw this, first you identify the force, then only we draw the resultant magnetic field. If the force acting downward, more magnetic field will be above. If the force acting upward, more magnetic field will be below. So now, okay, if I reverse the current, confirm you will move upward, yeah? So now I want you to draw the, wait, I forgot. This field, we got name for this. This is what we call catapult field. Okay, catapult field. We say in BM, we say medan elastic. Medan elastic. Okay, look at this elastic. Hello? If elastic, right? Elastic. You pull and then here, right? So, you see over here, if you pull upward and then release, it will go down. Right? So it looks like what? Elastic. Okay? So, I want you to draw the resultant the catapult field for this. Okay, draw the catapult field for this. And then one more, please go to the checkbox and then type. Please type your name and also the name of tuition center. Then after that, you draw the resultant magnetic field for this diagram. Draw the resultant magnetic field. First away. Okay. So first we identify the direction of current. Where is the current flow? Okay, sorry, direction of the force. Okay, where is the force acting? Okay, see over here, current where? Dot. Current is out. So the three fingers. This one's what? Current, right? So current, it must be towards. Towards. So current See, is towards. Can say right? Current is towards. And then turn north to south. Fire to the south. Fire to the south. Where is the thumb points over here? Your thumb points to the left. I repeat. Stop typing over there. Later you can type. Dot. Current is what? Outward. Current is outward. Current out. Third finger. And then magnetic field, I told you, always to the south. So turn to the south. Where is your thumb? Your thumb points to the left. So to left, make sure that you draw the arrow, yeah? That is, touch the conductor, draw the arrow to the left, and then please write the letter F to represent the force acting. Okay? Draw the direction of the force. Okay. If the force is acting to the left, what happens? You will see the majority of the magnetic field lines will go to the right hand side. So majority of the magnetic field lines will be on the right hand side. So we draw from here, goes to the right. Like this. Don't choose at the middle. If you choose at the middle, then it will be very close. Don't want. Later, in next class, we will go through more complicated diagrams. You must know how to draw. So from here, okay, if you already know that force acting to left, so magnetic fields, you see the 4 fingers over here, moving to the right, then you are spread. So that means it will, more magnetic field will be on the right hand side. So then we draw this curve. Must practice to draw. So more magnetic field lines on the right, and then on the left hand side, if you only one enough, then this is a resultant magnetic field that we call it as catapult field. Yeah? Catapult field. So what we did, we use the Fleming's Latin rule to identify direction of force, then only draw the magnetic field. This is the easiest way. But normally that's what you will do. So you ask the student to draw first, then only the force. Do I? It will confuse you. Okay, so we use the Fleming's left-hand rule first. Okay, so this is the main. But next week, I will repeat this again. Okay, I will ask you to draw some diagrams. Then only we go to the turning effect. Turning effect, then experiment, then only DC motor. Then we can close this up. So DC motor will take time. So I will send you one paper to the group. Please print out and then keep. Yeah, so that you don't need to draw. Just need to label only. Okay. Thank you very much for today's class. If you have any question, you can ask after the class. Yeah. Okay. Make sure that before you exit the group, exit the meeting, please type your name and the name of tuition center. I will repeat this again. Don't worry.
Sir,
Yes.
sir, how to draw the current flow, sir?
Yes. Repeat.
How to draw the current flow?
Where current flow? This one.
Yes, sir, that one, sir.
Okay. Actually, this dot is a front view. It shows that current is out of the surface. That's right.
No. The arrow one, sir.
Yeah.
The arrow one.
This one.
No. Yes, that one.
This one.
Yes, that one, sir.
This one is not current. This one magnetic field. Direction of the magnetic field. This is the current. Direction of the current. You see, the cross over here current is into the surface. But
Okay, sir. Now I can understand, sir. Sorry, sir. My mistake.
okay.
Thank you, sir.
Welcome.